and welcome to this video where we're going to be talking about code review. And first, I want to talk about why code review matters, what we're looking for, some real examples, and how to do this well, right? Based on industry standards. So what are we going to talk about? Well, first, I want to talk about why code review is a standard practice in professional software teams, what we get out of it, and why it exists. Then we're going to talk about the 4 things, or at least 4 things, that reviewers look for. So what are code reviewers looking for, or what makes you a good code reviewer when you are reviewing code? Then we're going to distinguish between issues a reviewer should flag versus issues better caught by automated tools. And then the connection between code review and like a team project workflow. So the first thing we're going to talk about is really why code review exists in the first place. Because I think what a lot of developers do, especially when they are just getting started, is they push code and they open pull requests and then they're just like, does it look right? And we need to be deliberate about what right actually means. And in my opinion, code review is one of the most valuable and most underused practices in software development. It's really something that should be required for team projects. So why does it exist? Why do I think that? So I want to start with a core problem that ultimately code review solves. And maybe you haven't been programming for very long, but I think this is something that everyone can kind of relate to. And it's ultimately about the blind spot that gets created when you have authored something. So every developer, no matter how good you are, has blind spots, things you didn't think to check, assumptions you didn't realize you were making, edge cases you didn't consider. And the person who wrote the code is often the worst person to review it because they'll read what they meant to write and not what they actually wrote. So when we have a second set of eyes, it often will catch what the first set has missed. And really, that helps us prevent a couple of different things. So first off, studies consistently show that code review is going to catch 60 to 90% of defects before they reach production. And again, it's just because we are often blind to the fact that we made assumptions, or we didn't think the problem through fully, or we just got really caught up in the forest and missed some trees. So when you compare that to testing alone, testing is excellent at confirming what code does, but only code review catches why it does something and whether or not it does the right thing and whether it will cause problems down the road. So bugs caught in review cost essentially a fraction of bugs caught in production, and fixing a defect before it ships is always cheaper than fixing it later. And there are some secondary benefits beyond finding bugs. Some of this is knowledge sharing. So reviewers are going to learn about parts of the code base that they didn't write, and authors get a second opinion on their design choices. Consistency is important. Code review is how a team ultimately enforces a consistent style and patterns and quality across all of the project contributors. And then accountability means knowing your code will be reviewed, which ultimately changes how carefully you will write it, right? Because it's that observation theory that if no one is looking at me, I might act differently than if I think someone is looking at me. And so when we know someone's going to look at our code, we will write it better. So when we talk about things like branch protection, right, in our repo, a branch protection rule requiring one approval isn't just about gatekeeping, but it's going to ensure that every line of code that reaches the main has been looked at by at least 2 people, and that is ultimately going to increase code quality. So ultimately, the big point I'm trying to make is when you find a bug, when in that cycle, matters. If we find it during code review, it doesn't cost us ultimately in manpower, time, thought, lost customers, lost revenue, downtime, anything a bug might actually impact. It doesn't cost us as much, right? It's a comment and a commit. If we find it during testing, we've spent debug cycles, we've spent test reruns, we've spent cloud resources for our CI/CD tooling, we've spent manpower. But if we wait and we didn't catch it until after release in production, then we have incident response, hotfix, data cleanup, reputation damage, all kinds of problems. So again, branch protection rules are important. So what do reviewers look for if you are submitting code to a repo and you are interested in how to do that well and make sure that your pull requests are received nicely by the reviewer? Or maybe you are just looking to improve your own review skills. Let's talk about what good reviewers look for. So, some categories. What should we check? And everyone has the library app. I'm going to use some examples from the library app to kind of tie this back to some code. But these are the 6 categories we're going to check: correctness, error handling, readability, design, test coverage, and security. So let's look at some code examples to go along with each one. So first off, correctness, right? Can we spot the bug? Does the code do what it's supposed to do? Does it handle edge cases? This is a C# example here in case that's maybe not your forte. So a reviewer who reads this carefully is going to notice, right, that, and I've got it in the comments there to help you out, a less than 0 means the last available copy can still be checked out, and then available copies is going to go to -1 before that guard fires, and this is going to create a situation where a book can be checked out, but it shouldn't be. Categories 2 and 3 about error handling and readability. Here's a couple of examples in some code here. What happens when inputs are null, empty, or out of range? We want to check, does the code handle them gracefully, or are we going to crash? So if we take a look here, we always want to look at the error handling of the situation. So it's going to return a book. We've got this where clause, but again, they're in the comment to help you out. What if Q gets returned as null? This doesn't have a try catch or anything in it. It's just going to crash. And then issues of readability. We also want to think about naming. If someone is reading this in 6 months, do they understand what it does? Is it clear? Can we rewrite this into a better piece of code that is more clear and more readable? Things like design and logic. Is the approach reasonable? Are there simpler ways to accomplish the same thing? Is anything duplicated that shouldn't be? Are there magic numbers, right? Hard-coded values in the code. So really the reviewer is going to ask themselves a lot of questions about your logic and your design. And then for test coverage, we want to know, did the author write tests for what they changed? And if a new method was added, are there tests for the happy path and for the edge cases? And reviewers really, asking ourselves, if there's no test for what happens, like in our library app, the find by ISBN, if it returns null, should we add one? That's a valid review comment. That's the kind of thing a good reviewer should ask. And then as we get into security, I'm just going to briefly mention, because we're going to go a little deeper on security here in a little while. Are there any obvious security issues? Hard-coded secrets, user input passed directly into queries, sensitive data being logged. those are the kinds of things that are immediately going to raise up some red flags, and then we'll dig into some deeper security issues as we move into our content. So what reviewers should not do, which is sometimes just as important as knowing what to do. But there are a couple of things that we don't want reviewers to do. If we want to be a good reviewer, these are things that we want to avoid. One is bike shedding. This is where we spend 10 comments arguing about whether a variable should be I or index or counter, or things that ultimately waste everyone's time, that don't ultimately affect correctness or any of those principles that we just talked about. So there's an actual term for that, bike shedding. You can look into why it's called that, but don't do that. Just move on. Don't enforce style manually. So if your team has a linter or a formatter, which if you're not sure what those mean, that's okay. We'll get into it later. Style issues should get caught by those tools automatically, not by humans. If you are a reviewer and you are writing comments like put a space after the comma 40 times, that's not code review. That's not doing any good. That's not going to help with code quality. I know we talked about the idea of consistency, but that's what linters are for and formatters. We have tools for that. Don't be the reviewer who approves things without reading them, right? Actually engage with the code. If the pull request is large, see if you can break it down into pieces, see if you can get multiple people on it. Try not to skim, actually review. And the LGTM looks good to me, right? And then just passing it. Unless it is an extremely negligible pull request, don't be this reviewer. That doesn't help anybody. And then don't review everything at once, right? If a pull request has like 500 lines and it's huge, you're not going to be able to give quality feedback on all of it. You need to chunk this out. Large pull requests really should be broken into smaller ones. And if you are maintaining a larger repo or maybe an open source repo, that is a good rule to put in to say like, hey, your pull request, if over a certain amount, is not going to get reviewed, it's going to get returned because you need to break it into smaller chunks. That is a completely reasonable thing as a maintainer to ask. And then if someone is submitting pull requests this large, maybe if it's a one-off problem, you could take the time to chunk it out yourself. But otherwise, it's just a bad plan to sit down and try to consume all of that code. You're not going to do very well. So some key takeaways from this section, right? We want to understand what code review is and that it's a skill. It improves with practice, like any other form of communication. The more you review, the better you get at spotting the kinds of problems that slip through. And ultimately, I think it makes you a better developer because you are looking at lots of different ways to solve problems that maybe you wouldn't have immediately thought of. So as you're going through this week's code and exercises, you're getting a chance to write some code review. And we want to think about, like, what are those 6 categories? How do we think about a good review and how do we write one? And then we'll look into the next video, which is going to cover some etiquette. So like how to give and receive feedback without like making it personal or hurting people's feelings, and take a look at some GitHub UI to make sure we understand how that works. So thanks so much for watching this video. Let me know if you have any questions, and happy reviewing.